Hello everyone, I'm glad you joined me in this video. I'd like to share with you this Perlin noise array generator that I created with the help of CHATGPT 3.5, which was a very interesting conversation. Of course, I'll put the link to that in the description below, but let me explain what you're seeing here. So we have some noise being generated on a texture, which is then applied to a material and then applied to this plane. And we also have some values that are being generated over here. And so this noise is Perlin noise, and you would use it because you want to generate some values that are organic in nature. So perhaps maybe you want to generate some temperature values or barometric pressure reading or something that fluctuates with natural organic, let's say, fluctuations. And also maybe you want to use this for procedural terrain generation or for other uses, especially inside of your blueprints. And to explain what I mean by that, let's get out of here and I will show you. So the functions that come with Unreal Engine are a little bit limited and inadequate. You know, they don't really come with all of the different types of parameters that you normally would be able to use to create your Perlin noise. And so, you know, if Perlin noise could be made to be, let's say, very, very bumpy, or it could be really smooth. And these functions don't really give you control over how that noise is being generated. Now you can create noise in a material, but a material is interacting with the GPU directly, and so therefore it's very difficult, if not impossible, for you to sample the noise inside the material, especially while it's moving or scrolling, or to generate, let's say, infinite noise and continuous sampling. So this was a really good solution for generating this noise for use inside of a blueprint. So let's get into that. And so here's the first node that you would get once you install the plugin. And this one is the one that actually generates the array. It's not necessarily a texture, it's in a two-dimensional array. And that makes it just much easier to sample. So here's the function for sampling. And then finally you can turn it into a texture and select up to 4 colors to colorize the texture. So these are the 3 nodes that come with the plugin. And so to get into it a little bit further here, when you're generating your array, the 5 most important parameters here are going to be your frequency, the seed, the scale, octaves, and persistence. And it's kind of difficult to explain exactly what all of these do, but I'll just give a quick rundown in that, just like the grid we have here in our blueprint, you know, we have a grid pattern. You can say that the noise is being generated in somewhat of a grid pattern, and the frequency is how often or how close the interval of the grids are. The seed is a special number that maintains continuity every time the noise is generated. This is what allows me to scroll. You can scroll through the noise endlessly, and every time the noise is generated, it's continuously the same noise. If you don't put a seed in here, every time you run this function, you're going to get completely different noise. So the seed is very important for continuity. The scale is the range of numbers. So the full scale is 1. This is the maximum you can set this to. And that means that the output of each value in the array will be somewhere between 0 and 1. If you change this, like let's say to 0.5, then the values won't range as high as 0 to 1. They'll only range the range will be 0.5, and I believe that it means that the values would start at, like, let's say 0.25 and then end at 0.75, but I'm not 100% sure about that, but I do know that this changes essentially that range. The octaves are essentially how many times the algorithm to create the noise is iterated over, creating more and more, let's say, detail. The more octaves there are, the more detail you're going to be able to get out of the noise. With just one octave, you're going to get really, like, let's say, rolling hills, very smooth, round features. With higher octaves, you're going to get more of that like swirling cloud effect with like fine features. And so just demonstrate that, let's change some of these. Oh, lastly, there's the persistence. And persistence also changes the amount of detail, but I'm not 100% sure exactly how. But I just know that a higher number of persistence will create more detail. So to give you an example here, let's set the octaves really high. Let's put that at 8. We'll set the frequency to a slightly higher number. And we'll change the persistence to a slightly higher number. And then we're going to compile this and run it. And now you can see that the noise that's being generated has a lot more detail. And that the values now that are being sampled are going to be more erratic because the noise is more erratic. And so we can get out of here and go back over to here, and I can explain now the other nodes. And the sample noise at location is very simple to understand. It's just literally taking whatever value is at this location and then returning it, and then we can now print it and see what that value is. Of course, you can use this value for you know, like I said, your temperature reading or your barometer or whatever. And then lastly, we have the ability to colorize it. And it uses exactly all the colors that are not black. So if I turn these two colors to black, and then we compile that and run it, you'll see now that it is entirely blue. And if we go, and it doesn't matter which color you select, you can skip a color if you want. It just won't use the black color. There will just now be two colors. And the lower number color is going to get the lower values, and the higher number color is going to get the higher values. And the colors will be interpolated so that as the values change, as they move from lower to higher or higher to lower, it's going to gradually change from one color to the next. So there's no boundaries in the colors. And so let me show you how I'm applying that. So I am, firstly, you need to make a material, and it's very simple. You can just take this material, and you need just one input parameter for a two-dimensional texture. I've connected it directly to the base color. I've named it Perlin texture. And then with this material, let's go ahead and close this. With this material inside the blueprint, at the beginning of the blueprint here, let's get here, I immediately take the plane that I created. I've set a plane inside the viewport, and we're going to assign a dynamic material instance. I'm going to give it that material I just created and set that to a variable. And here I'm creating a timer function so that we can loop through and continuously scroll. And here you can see that I'm basically, each time the function is called, we're just increasing the counter. I'm increasing it right now by 5, but you can increase it by however much you want. And then we're finally calling this function that I've been showing you. And so that's how you can take the texture that's been generated and actually apply it. Take the dynamic material and then set the texture parameter value for that material to what you named the input for your texture parameter, Perlin texture, and then you can apply it so that you can see it. And so now you can use this if you wanted, let's say you were generating some kind of heat map value or air pressure value, and you were generating both let's play this again. So you could imagine that the values here are controlling, let's say, your temperature, and then you can actually provide on screen in game some kind of heat map that's colored in the way that you like, that provides, you know, some kind of sense of where this data is coming from. So now keep in mind there's a couple caveats with this plugin, and that is that because it's a blueprint function and it's not running on the GPU, calculating noise like this is very intensive. It does take a lot of processing power. So this isn't something that you want to put directly on the tick or even call too often. Now you can see I'm still getting 60 frames per second. So no worries there with how often I'm generating new noise, and the new noise that's being generated is the new noise that's appearing. Let's say the whole thing is scrolling, so some new noise has to be generated, and so that doesn't really take up too much processing power. But if you were to put this on the tick, it's definitely going to crash your computer. So keep that in mind. Anyway, in this next session, I'll show you how to install the plugin, and so you can use it for yourself.